Hi and good day. My name is Yong from Group 6 of SEAA3022 IDP1 Section 2. This video will be about my minor presentation on erosion and sedimentation control, water reticulation, and also cost and estimating. First of all, I will start with the erosion and sedimentation control presentation. What is actually erosion and sedimentation? Soil erosion is the detachment, entrainment, and transport of soil particles from the ongoing development and construction areas, either due to the impact of raindrop or by the shear forces of water flowing across the soil particle. Sedimentation is the build-up of sediment generated by the erosion process deposited on the land or in lakes or streams. Main objective of the erosion and sedimentation control are minimizing the soil erosion and hence reducing the water pollution caused by the construction activity. In this project, the guideline used for the erosion sedimentation control design is the Urban Stormwater Management Manual for Malaysia, MASMA 2nd edition by the Department of Irrigation and Drainage, Malaysia. This figure shows the final layout design of ESCP in the project area. The whole project area is distributed into 3 catchment areas which are upper, middle and bottom part. The area for these 3 catchment areas are as labeled. In this figure also, we can see that the location of sediment basin, stockpile, temporarily earth drainage, wash bay and silt fence. For ESCP department, their main job scope include runoff management, sediment and erosion control. In runoff management, they are required to estimate the rainfall and also peak discharge flow using the rational method as recommended by MASMA. Temporary earth drainage is then designed to cater the runoff. The trapezoidal-shaped open channel is chosen because it is able to cater the larger water flow. For sediment control, soil loss and sediment yield are estimated using the universal soil loss equation and modified universal soil loss equation respectively. Sediment basin is then designed to trap and retain the sediment and other larger particles from being discharged out from the construction site. Other erosion control include silt fence, wash trough, and sieving and planting. The dimension for the design of temporary earth drainage is as shown in the table. The highest cubic for the project area is 1.681 m3 per second, occur at Zone B, Drainage 4. Drainage 4 is designed to cater 1.768 m3 per second, which is adequate to cater the cubic. These two figures are the cross-sectional views and long-sectional views of the design temporary earth drainage. The dimension include the top width, bottom width, depth, and also the side slope of the temporary earth drainage are shown in the diagram. For the design of sediment basin, we can know the overall basin dimension from this table. There are a total of 3 sediment basins for the whole project area. There is one for upper, one for middle, and also one for bottom part of the project area. Basin 2 need to be designed as the largest dimension because it needs to cater for the largest catchment area. This is the plan view and also the section view for the sediment basin. Next, I will present about the water reticulation department. The main objective of the water reticulation department is to design the network of pumps, pipes, and water storage to store and distribute water. In our project, we are required to propose the pipe layout, determine the water tank size, pipe size, and pipe type. Factors to be considered when choosing the size of the pipe to be used include the pipe location, the plans for future expansion, calculation of the likelihood of leakage, various pressure factors, and how close these pipes are to the fire department, and also the volume of water required. There are 2 guidelines used by the water reticulation department, which are the Uniform Technical Guideline Water Reticulation and Plumbing by Suruhanjaya Perkhidmatan Air Negara Span, and also the Water Demand Guideline by Syarikat Air Johor SAJ. Before we design for the network of pipe, we are required to plan the pipe layout and estimate the water demand first. For the design of water tank, the height must be 5 meters above the ground to ensure adequate pressure head and to facilitate the gravity flow. For the size of pipe, we use the pipe with diameter of 100 mm, 150 mm, 200 mm, and also 250 mm. Type of pipe used is the PVC that can withstand a high pressure. This figure shows the pipe planning layout for the whole project area. The left-hand side is the upper part, while the right-hand side is for the lower part of the project area. There is a total of 12 loops, 31 knots, and 39 pipes proposed for the project area. By using the ePlanet software, we can determine the velocity, flow rate, and pressure head of the water distribution network easily. This is the design of our water tank. We decide to use a diameter of 25 meter with a height of 7 meter for our water tank based on the water demand of 2,200 meter cube per day. From the result obtained from ePlanet, we can know that the highest pressure head is 28.73 meter occur at knot 22, while the highest velocity is 0.4 meter per second occur at pipe number 5. Now we will go to the costing and estimating department. The main objective of the costing and estimating is to determine the most economical materials and machineries used for the project. Not only that, costing and estimating aims to prepare a budget and control the cost for the project effectively. In costing and estimating, we will mainly focus on the earthwork process. The machinery used for the earthwork include dump truck, chainsaw, excavator, bulldozer, backhoe, and also compactor. We decide to rent all the machineries for the earthwork activity since it is more beneficial to save the budget, as new machine will involve the interest and loan payment. The cost for earthwork processes involve the cost for site clearing, the cut and fill work, and also the finishing work. For site clearing, we need to consider the cost for tree cutting and disposal, and also the topsoil removal. While for the cut and fill work, we need to consider the cost of cutting and filling to formation level, and also the transportation. For finishing, leveling and compaction costs need to be considered. This table shows the total cost and total time before and after reduction. The percentage of reduction is approximately 7.5%. The cost reduction is due to the redesign of proposed level by minimizing the cut and fill volume to reduce the cost for the earthwork. Due to the reduction in cut and fill volume, the total time for the earthwork have also been reduced from 22 weeks to 18 weeks. Hence, the final total cost required for earthwork project is approximately 7,930,000 ringgit. This table shows the total cost after the reduction for each of the components involved in earthwork. For the site clearing, we need 549,000 ringgit, while for the cut work, we need a total of 3,317,000 ringgit, which contribute the largest part for the total cost. 1,010,000 is required for the field work. Last but not least, the finishing work will require a 3,043,000 ringgit. The total cost for all the processes involved is 7,927,000 ringgit. I think that's all for my minor presentation. Thank you for your attention.